Hi, and welcome to this very interesting course on getting started with OpenAI o3-mini. Now, you might know that OpenAI has released their o3-mini series of models at the end of January 2025, and this is their newest, most cost-effective reasoning model after o1. And it is powerful, but also it is fast and effective in terms of giving answers to simple as well as complex questions. So the idea of this course is to dive deeper into the o3-mini series of models, understand it from a conceptual perspective, compare it with other models in terms of performance benchmarks, as well as take it out for a test drive by doing some hands-on. So the key things we will be covering throughout this course includes obviously getting to grips with OpenAI o3-mini. So we'll understand what is OpenAI o3-mini, what are its key features. Then we will look at some performance benchmark results released by OpenAI and kind of do a comparative analysis of how does this model do against other similar models. And we will also take OpenAI o3-mini out for a test drive via ChatGPT to get started with and compare it with several other popular large language models and see how does it do on certain reasoning problems. Next, we will learn how to access OpenAI o3-mini via the API, compare various LLM APIs, mostly focusing on reasoning LLMs. So we'll compare DeepSeek R1, which was released recently. Do check out some of our free courses on DeepSeek, which we have also released. And then we'll also compare OpenAI o1, GPT-4o against o3-mini on a variety of simple as well as complex reasoning problems. And at the end, we'll also compare the three different levels of o3-mini available in terms of their reasoning level, which is low, medium, and high. I'm Dipanjan, you can call me DJ, and I'll be guiding you throughout this course. So let's get started with OpenAI o3-mini.
Just a quick note, Analytics Vidhya has 100 plus free courses from beginner to advanced on topics like machine learning, generative AI, agents, etc. Complete with certification. Click the I button to explore now.
Welcome back. So let's understand what is OpenAI o3-mini. Now, OpenAI, the organization behind ChatGPT, has recently released OpenAI o3-mini, which is the newest and the most cost-effective reasoning large language model, specifically in its reasoning series of models. Now, this was released at the end of January 2025, where OpenAI mentioned that they are releasing OpenAI o3-mini, which is the model name, and it is available in both ChatGPT and also in their API. And overall, this is one of the most powerful models, not only in terms of reasoning power, but also in terms of speed. And this is their first small reasoning model that supports highly requested developer features, including function calling, very useful for agents, structured outputs, which is a weakness of LLMs, where the idea is instead of just generating text, can you generate output in structured formats like key value pairs, JSON, as well as developer messages, making it production ready, which is a very interesting thing. And OpenAI's o3-mini also supports streaming, just like its other models. And this is the very interesting bit that developers can choose between three reasoning effort options, low, medium, and high, to optimize for specific use cases, where the idea is if you set the reasoning level to high, then the o3-mini model will reason more, and this is very useful for more complex problems. However, for simple problems and actually even medium to more complex problems, you could even use the low reasoning effort in the model. So this is a setting which comes in the model itself, and we will see how to use this and compare the results of the same problem against low, medium, high later on in the course. Now, one drawback of this model is that o3-mini does not support vision capabilities, which means you cannot upload images as opposed to, let's say, if you are using GPT-4o, which supports vision capabilities where you can upload images, ask it questions, and so on. Now, let's understand a bit more into how did OpenAI get to releasing o3-mini? What was the overall evolution journey? So this is the evolution of models released by OpenAI, where they started off with GPT-1, which was their initial transformer-based model released in June 2018. Around the time when the Attention Is All You Need paper was released, and then came the BERT transformer, and the GPT-1 transformer model was released around that time, and it marked a pivotal advancement, especially with sequential transfer learning in the context of NLP in terms of releasing pre-trained and then fine-tuned language models. And GPT-1 was one of the initial very popular decoder-based transformers used as a language model, where it was an expert in auto-completing and generating text. And then we got GPT-2. So this is known as the rise of the giants, because this is where the really larger language models started coming into play, smaller by these days standards, but larger in those days. So this was introduced in February 2019 with a massive increase in parameters to 1.5 billion. It was more capable, gave better results. And then we got GPT-3, which was known as the powerhouse, released in around June 2020 with an astounding 175 billion parameters. And it was trained on a dataset of approximately 570 gigabytes. And we got a variant of this GPT 3.5, on top of which the first ChatGPT version was released, which we now consume as a product. And now, of course, we have newer models, which came out after that, which was the GPT-4 family of models, GPT-4, 4 Turbo, 4o, which is the next frontier. And GPT-4o is the latest in the GPT-4 series of models released by OpenAI, which is a multimodal large language model, adept at generating high-quality text responses and performing complex reasoning tasks and processing multimodal inputs, which is one of its most interesting features, where it can understand image, audio, text, and then generate a text response. And after this, we also got some interesting models where OpenAI ventured into reasoning models. So this was the evolution from regular large language models to more of reasoning-based large language models, where OpenAI released o3 and o3-mini. And the o3 series of models were trained with large-scale reinforcement learning to perform complex reasoning using chain of thought. Now, chain of thought was a prompting technique, or is still a popular prompting technique, which was released before that. The whole idea is to let the model not immediately generate a response to your input question or prompt, but basically think about it step by step, solve those steps, and then get to the final answer. And OpenAI integrated this into the training process of o3 itself. And recently, in end of Jan 2025, they launched o3-mini, which is the first small, cost-effective reasoning model specialized for coding, STEM, and logical reasoning problems. So to summarize the key aspects of o3-mini, it is the most cost-effective model in the reasoning series, available in both the ChatGPT web interface and the OpenAI API, which you can connect with Python, which we'll look into later on. And o3-mini supports some of the key developer features, including structured output responses, function calling, batch API, and more. And it is designed to excel at STEM, science, technology, engineering, math problems, logical reasoning problems, as well as coding tasks. In terms of availability, so there is general access available now. It is available to all ChatGPT users. ChatGPT Plus, Team, and Pro users can use o3-mini with enhanced capabilities. Usage limit is up to 150 messages per day. In terms of the model, right now, the latest model version is 31 January 2025. That's the o3-mini version. In the future, maybe you will see some newer versions being released. The context window is 200,000 tokens, which is a pretty large context window, definitely more than GPT-4o, which is 128K tokens. And maximum output tokens is 100,000 tokens. There are three major levels of using OpenAI o3-mini. There are the low reasoning level, medium, and high reasoning levels. In terms of if you are using o3-mini with the low reasoning level setting, it performs basic reasoning and handles straightforward queries, often offers direct answers with minimal logical inference. Not that it doesn't do it, but it'll do less of it. It'll break down complex problems in lesser steps and try to give you the answer quickly. Typical use cases like fact retrieval, simple question answering, executing some commands which are not too complex, and basic tasks like summarization, translation, and so on. If you are using the medium reasoning level setting, the key features include balancing between efficiency, giving the answer faster, and improved reasoning depth, breaking it down into a bunch of steps trying to get to the answer. Capable of handling moderately complex queries and providing multi-step explanations. Again, typical use cases solving moderately complex problems, instructional content that may require a few layers of processing before you get to the answer, typically for logical reasoning problems. And if you're using the high reasoning level setting, delivers advanced reasoning with robust multi-step inference, excels at understanding complex, abstract, nuanced context, which means it is not very straightforward. There could be pros, cons. It may evaluate different alternative approaches to get to the answer. And typical use case is to solve complex problems where you need some detailed logical reasoning, problem solving, detailed analysis. Now, in general, it's not like the low reasoning level cannot be used for reasoning problems. In fact, you will see it performs pretty well. So I would say based on your scenarios, your problems, feel free to play around with the different reasoning levels and choose what works best for your responses. In terms of the key features of OpenAI o3-mini, enhanced reasoning, excels in tasks requiring logical reasoning and problem solving, improved coding capabilities. Codeforce's benchmark test indicates that o3-mini with the low reasoning outperformed the o1-mini, while giving the o1 model, which is a larger reasoning model, a tough competition, which means the o3-mini series of models are really good in understanding and helping with coding tasks. And of course, the most important thing which I find really interesting with this release is faster response times. O1 can sometimes take really long to respond even to simple questions. o3-mini is really fast, even faster than DeepSeek R1 in many cases. So users experience quicker interactions, enhancing overall user experience, obviously. Welcome back. In this video, we'll take a deeper dive into o3-mini in terms of looking at some performance benchmarks and pricing analysis. So let's see how o3-mini performs on different benchmarks versus other OpenAI large language models first. Now, one of the very popular benchmark datasets is the graduate level Google Proof question and answering benchmark dataset, also known as the GPQA benchmark dataset. So the GPQA dataset is basically a challenging dataset which has been curated over time of 448 multiple choice questions written by domain experts in biology, physics, and chemistry. So it's interesting to see how does o3-mini stack against other previous OpenAI models in terms of this benchmark dataset. And as you can see, it does a pretty good job based on the visualization on the right-hand side. o3-mini, especially the high reasoning level, excels in this dataset, making it OpenAI's most advanced model in natural language understanding as compared to the previous reasoning models, o1 series of models. Then we have the AIME benchmark, which is the American Invitational Mathematics Examination, focusing on math problems. In this one, again, the o3 series of models have performed pretty well, especially the medium reasoning matches o1 level of performance, more or less, and the high reasoning model variant excels with 87.3% accuracy in mathematical reasoning, offshooting by almost 4% the o1 model's performance. And then we have Codeforce's ELO score. So this is a benchmark which was introduced some time back, which is competition coding benchmark designed to accurately evaluate the reasoning capabilities of LLM based on, again, coding tasks. And the idea is to see how well can LLMs perform in a variety of coding tests in the benchmark dataset. And as we can see that the o3-mini series of models has surpassed o1-mini in coding, with its medium and high versions outperforming all other previous o1 variant of models, making this OpenAI's best yet in this benchmark. And then we have the software engineering benchmark, SWE bench. And this is a benchmark focusing on software engineering problems like can large language models resolve real-world GitHub issues. So the focus of this is, can they solve a variety of typical problems faced by software engineers, and can they solve it? That's the whole idea of this benchmark. And as we can see that on the SWE benchmark, o3-mini with the high reasoning level effort is the best model, surpassing the previous scores obtained by the o1 series of models. And the low and medium reasoning effort models also do pretty well in general. And then we have the frontier math benchmark, where the o3-mini with the high reasoning level excels in math, performing nearly twice as well as earlier versions in the Frontier Math benchmark. So it's doing way better in math problems as compared to the o1 series of models. And then there's the live bench coding benchmark, another code-based benchmark where, as you can see from the table here, all the o3-mini versions surpassed o1 in the live coding bench generation, with the high version excelling in code completion also. So basically, they focus on code generation and code completion tasks in this benchmark. And o3-mini has done pretty well in terms of code generation as well as code completion across different reasoning levels. And then we have general knowledge based benchmark where tests show that o3-mini, especially the high reasoning version, is better than o1-mini with small gains in math and science, but nearly twice the ability in basic question answering and reasoning. So the MMLU is one of the most popular benchmarks used across different LLM evaluations. And in terms of general math and factuality based reasoning and question answering, o3-mini does pretty well all around. And this is definitely interesting to see that it performs even better than o1-mini in many of the areas. Now let's compare o3-mini performance with some of the other latest popular large language models. So looking at the GPQA benchmark again, and as you can see now, we have many other large language models besides the OpenAI family of LLMs. So here, both the o3-mini with the medium reasoning and the high reasoning outperform even DeepSeek R1 and Claude 3.5 in detailed factual question answering tasks on the same GPQA benchmark. So that is a pretty interesting aspect that OpenAI's o3 is like the full-fledged model, but even the mini model, which is what they have released and what we are focusing on right now, the medium and the high levels are performing way better than models like DeepSeek R1, which was released recently, and also Claude 3.5. Coming to the AI ME benchmark, focusing on math, the o3-mini, again, medium reasoning rivals DeepSeek R1, as you can see here. Very, very similar performance, while the o3-mini with the high reasoning level outperforms it by almost close to 10%, showcasing its dominance. Codeforce's ELO score, o3-mini medium and high, which you can see on the right-hand side, surpass DeepSeek R1 in coding. It performs way better than DeepSeek R1, holding the highest ELO score amongst all models. In terms of the software engineering benchmark, Claude 3.5 remains the top performer here in real-world software engineering tasks, but o3-mini high closely competes with it. As you can see, it's very, very close. And this slightly surpasses DeepSeek R1. So I would say they are on pretty much the same level. o3-mini high, DeepSeek R1, and Claude 3.5 in software engineering tasks based on the benchmark. Coming to pricing comparison analysis, so this is the table showing some of the popular models out there. We have GPT-4o, OpenAI o1, DeepSeek R1, and OpenAI o3-mini. So overall, again, in terms of input token cost, DeepSeek R1 is the cheapest, but the interesting aspect here is that o3-mini is a newer model, but it is way cheaper than GPT-4 as well as o1. Cached input, again, DeepSeek R1 the cheapest, but o3-mini a very close competitor and way cheaper than 4o and o1, its previous family of models. And in terms of output token cost, again, DeepSeek R1 is the cheapest, followed by OpenAI's o3-mini, which is actually could be a very good replacement now for GPT-4o in many cases, except multimodal problems. Welcome back. In this video, we will see how we can access OpenAI o3-mini via the ChatGPT web interface. So free tier users of ChatGPT, those who are not subscribed to either ChatGPT Plus or Pro, you can also experience o3-mini by selecting Reason below in the message box, and then it would use the o3-mini model. In general, if you have an account and if you have a subscription like ChatGPT Plus, Team, and Pro, these users can directly select o3-mini or the o3-mini high, that's the reasoning level high variant, from the model picker drop-down list at the top, as you can see here. And then it will use that model based on the prompts which you type in. It will send it to that model and you will get the responses. So now let's try OpenAI o3-mini in ChatGPT with a couple of examples. So right now I'm in chatgpt.com. This is my homepage, and I'll take one of our articles which was written recently, 5o3-mini prompts to try out today, and I'll take one of the prompts from this, basically around writing a coding function or telling o3-mini to write a coding function to solve a particular problem. So first, from the drop-down, select o3-mini. Now I'm selecting o3-mini high because it is great at coding and logical problems, but you can also select o3-mini. And then I put in the prompt, write a Python function to validate email addresses. The function should check for the following criteria: the presence of an @ symbol, valid domain name, valid username format, and the function should also handle potential errors. So now you can see it is reasoning, and then it is designing the email validator, and you can see the thinking steps also. It is thinking about creating a function called validate email, and then it's checking for the presence of the @ symbol. Then it thinks that it can either use a regular expression or manually split the email to validate the username and the domain. And then it's starting to build the function. It has reasoned for around 17 seconds. These are, by the way, the reasoning steps, which are not shown directly. If you click on it, then it shows you what it is thinking about live. So here it is thinking how it will handle the errors. It is iterating on the function design. It'll start by splitting on the email and then check whether it is valid or invalid, the different aspects in terms of the domain and the regular name. And now then it starts responding after reasoning for 17 seconds. So these were the thinking steps. And now it tells us that below is one example of a Python function that validates an email address based on the criteria I described in terms of the key constraints which I put in the prompt here. And then, as you can see, this is the Python function with a nice documentation about what does it do. And then this is the actual code where it does some basic validation checks and then uses regular expressions and what are the allowed top level domains like .com, .org, and so on. And then it also gives us some code using which we can test some sample emails. And then it also explains how does it work step by step. So this is how you can use OpenAI o3-mini in ChatGPT. Let's try out the same prompt, maybe in just o3-mini with less reasoning. So what I'll do is I will just refresh chatgpt.com, go to o3-mini, not the high reasoning level, and I type in the same prompt. Now let's see how long does it take for it to give us a response. So now it is reasoning as we saw before with the high reasoning level variant of o3-mini. And you can see earlier it reasoned for around 17 seconds in the high reasoning level variant of o3-mini. Here with the regular model, it took half the time. And after its reasoning, it gives us a function, which is kind of very similar to the previous function. Maybe there are some steps which it did not add in, some additional checks, but overall, very similar in terms of the code itself. And it does follow the rules which we mentioned. So that's how you can use OpenAI o3-mini in ChatGPT. Just select the model in terms of whether you want the high reasoning level or the low reasoning level model, and then type in your prompts and get the responses accordingly. That's it for this video. I'll catch up with you in the next one. Welcome back. In this video, we will take OpenAI o3-mini out for a test drive in ChatGPT with some various interesting logical math reasoning problems. So let's get started. Now, the first problem we will tackle is a coding problem with OpenAI o3-mini. The idea is we will tell it to create a JavaScript animation. So the code will be in JavaScript where the word celebrate is at the center with fireworks happening all around it. So let's check out this example and what does OpenAI o3-mini do for this. So here's the prompt: create a JavaScript animation where the word celebrate is at the center with fireworks happening all around it. Now I sent this to the o3-mini model. And as you can see, it reasoned about creating this animation for around 25 seconds, which is not a small amount of time. But here it thinks about what did the user ask. And then it says it will create HTML canvas and write JavaScript to generate both the fireworks and also center the text accordingly with a proper alignment. And then it decides what it needs to build, certain functions, creating some particle effects, creating certain classes, and the text needs to stay in the center and overlay it. And then it is planning to spawn fireworks randomly within the canvas. And after 25 seconds of reasoning and thinking, it creates this entire code base for us. As you can see, it is completely JavaScript. These are functions to resize the canvas, randomly generate certain number of fireworks, and it has created classes for that. And it has then explained how does it work step by step, including the animation loop. So what we'll do is we will copy this code and we will type it into a real-time HTML editor, and we see whether the code works or not. Of course, we could save it on a file locally in an HTML file and do it, but this is fast. So let's paste the code here, and we can see that the word celebrate is in the middle and there are fireworks happening all around it, which basically means o3-mini has solved the problem for us perfectly in the way we described it. Pretty interesting. Now let's check out the second example. Now this is the second problem, which is also a coding problem. The idea is to tell o3-mini to generate a comprehensive code base in Python, which can load a dataset for sentiment analysis. Sentiment analysis meaning, given some text, the idea is can you predict whether it's a positive, negative, or neutral sentiment in terms of the emotion being expressed by maybe a customer, whoever is typing out that text. And we tell o3-mini the code it should generate to do this sentiment analysis in Python. It should try 3 different approaches. A lexical approach, which just looks at positive or negative words and computes the sentiment, like a Python library like TextBlob. Use a pre-trained transformer model, which is a language model itself. And finally, use prompting with large language models, and then compare the results at the end. So interesting aspect that it's not just a simple piece of Python code, but a bit more complex, where we are telling o3-mini itself to generate this code for us, where 3 different approaches can be tried out. So let's check out this example now in ChatGPT. So here I have used o3-mini in ChatGPT and given the exact same prompt, which we just discussed, to try out 3 different types of sentiment analysis in that Python code, which it should generate. And as you can see, it reasoned for around 18 seconds in terms of the 3 approaches I mentioned it to use. And it's pretty intelligent in the way that it already figures out what kind of fine-tuned transformer models are out there, which could be used for sentiment analysis, and that it could prompt LLMs using OpenAI or Hugging Face to solve that third approach of prompting to do sentiment analysis. And after 18 seconds, it starts giving us the response that it will try these 3 approaches. It gives us the installation code, which is pretty nice, what libraries you need, and then the code for comparing 3 approaches. The first approach is, by the way, it loads the relevant libraries, which is correct. And then it loads the sentiment dataset for us. In this case, it is using a sample dataset, the IMDb reviews dataset, which is the popular dataset for sentiment analysis. So even if we did not tell it to use a particular data set here, it picks up one, which is a sample one, which is pretty nice. And then positives are labeled as 1, negative is labeled as 0, basically. And then it uses or defines a function called sentiment text blob, which does the first approach, lexical analysis, where text blob can help in detecting the polarity, which is either positive or negative based on a particular score. And then it uses a transformer for the next approach, where it will pass it to a particular transformer model in this function. And the last one, it uses a large language model. And as you can see, it has created a prompt for us also for prompting the LLM, saying you are a sentiment analysis assistant, analyze the sentiment of the following text and respond with exactly 1 word, positive or negative. And it uses the OpenAI library. Now, overall, this is pretty good, but there is one mistake, but this mistake is with all LLMs. It is using the older OpenAI API. Now it is not called chat completion anymore. So the code is technically incorrect, even though logically it is correct. But from a syntax perspective, this is the older library, which is no longer used. But otherwise, it's pretty spot on. And then as you can see, for the second approach, it tells us it will use this Dilbert fine-tuned sentiment analysis model. So it does a nice job in then running the code in terms of the code which we can use to run the different models, and then check out the different scores in terms of using a scikit-learn classification report, which helps us in looking at the accuracy, precision, recall in terms of how well has the model classified positive reviews as positive, negative as negative, and so on. So it does a pretty good job, and it also explains step by step what it has done. And we also tried this out with the OpenAI o3-mini high reasoning effort variant, where it, again, reasoned for around 13 seconds, so not very long, and it generated code which is actually very, very similar to what we saw with the regular o3-mini with the low reasoning effort. So not that much of a difference. It still makes that same mistake because probably the data it was trained on in terms of OpenAI APIs and so on is the older version. So overall, a pretty good job. And it didn't really matter too much in terms of using the low reasoning effort versus high in this case. Let's check out the third problem now, where we tackle a different kind of a problem solving with o3-mini. So now we will tackle a reasoning problem with OpenAI o3-mini. The problem is pretty straightforward. We give it a logical problem saying you have 8 balls. One of them is slightly heavier than the others. You have a balanced scale, but you can only use it twice. How do you determine which ball is the heaviest out of those 8 balls? And now let's check it out on ChatGPT. So here I've typed in the prompt for o3-mini in ChatGPT. You have 8 balls. One of them is slightly heavier than all the others. You have a balanced scale, but can use it twice. How do you determine which ball is the heaviest? And then it reasoned for about 6 seconds, saying that the problem is solvable in 2 ways. And then it starts giving us the answer, saying first, divide the balls, label them first 1 through 8, and then group them into 3 groups. And then do a first weighing, where you put one group of balls on the left pan, one group on the right pan, and then you analyze the outcome of the first weighing in terms of whether the scale balances or the scale does not balance. And then after that, you can do a second weighing where you take the balls from the heavier group and then weigh them against each other, saying that with only 2 weighings, you can always determine which of the 8 balls are slightly heavier using the method of elimination. So it does a pretty good job in this case. Let's check out the next problem now, which we will tackle with o3-mini. Now, the next problem is also a slightly more challenging reasoning problem. So the idea here is there are 8 employees of an organization. They work in 3 departments, and they have a bunch of personal preferences in terms of choice of sports, where do they work, and all of that. Given all of this information, can we find out who are the employees who work in the administration department? So let's see how o3-mini fared in this problem. So here I've typed in the prompt about 8 employees of an organization. They work in 3 departments, which are personnel, administration, and marketing, with not more than 3 of them in any department. So those are the constraints. And then each of them has a different choice of sport, from football, cricket, volleyball, badminton, lawn tennis, basketball, hockey, and table tennis, not necessarily in the same order. And then we have some further information, like Dan works in administration, does not like either football or cricket. Faye works in personnel, with only Alex who likes table tennis. Earl and Harry do not work in the same department as Dan, which means using this information, it could figure out that probably these 2 folks are not in administration and so on. And in this way, we have a bunch of information about people who like a certain sport, may or may not work in a certain department. And then the idea is, who are the employees who work in the administration department? And then, as you can see, o3-mini reasoned for about 24 seconds, where it starts looking at it step by step by looking at those clues which we gave it in the prompt and starting to map the people to particular sports and departments. And after all the reasoning is done, it validates it also to make sure that things are making sense. And then it gives us the response, saying that employees are Dan, Carol, and Betty. And it also gives us the full-fledged reasoning in terms of why did it come to this conclusion, that these are the 8 employees. They work in 3 departments, each have a different sport preference. And then these are the clues which we gave it in the prompt. And then it starts doing the reasoning in terms of who is in which department, what are their sports, and then leveraging those clues step by step, one after the other for each person, to get to that final conclusion of what is the sport which every person likes and what is the department for each person. And then it gives us the final conclusion saying Dan, Carol, and Betty belong to the administration department. And it is absolutely correct. If you spend some time on this problem actually, and you could actually do this manually, you will find out that Dan Carol, and Betty are the folks who are actually working in administration. Now let's look at some other problems with o3-mini. So the next one is slightly different. Here we are tackling a STEM problem with o3-mini where we have a problem with a series RLC circuit. So it's more of a physics-based problem with some resistance, an inductor, and a capacitor. And the idea is to find out certain computations here in terms of the impedance, the current flowing, the phase angle between the voltage and the current. So let's check out how did o3-mini fare against this problem. So you can see here I've typed out the same prompt, giving it all the relevant values which are already available in terms of the resistor, the inductor, capacitor, AC voltage source, frequency, and so on. And it's a series RLC circuit. And then these are the things it needs to compute. And then it actually reasoned for just a few seconds, and then it started listing out all the relevant properties to start with first in terms of the different values, what it needs to calculate, and then it starts calculating it step by step, leveraging the relevant formula to calculate each of these values, and it gets the response, which is actually correct. So it does a pretty good job in solving this physics problem. Let's check out the last problem now with o3-mini. So this is an interesting kind of a puzzle-based math problem where the idea is in the World Government Summit, all leaders shake hands with each other just once. So how many handshakes will be there together if there are 15 leaders? And we give it the 4 choices also. It's a multiple choice question. So let's see how did o3-mini fare on this problem. So here I've typed in the problem. In the World Government Summit, leaders shake hands with each other once only. How many handshakes will be there together if there are 15 leaders? And these are the options. And then it, again, reasons for just a couple of seconds. And you can see it has already figured out the math combination formula, which is NC2, and which is this formula. And then it says that to determine the total number of handshakes, each handshake involves 2 leaders, and each pair shakes hands only once. You can solve it using the combination formula 15C2, which is n times n minus 1 divided by 2, and we get the answer, which is the o3-mini does a pretty good job, and it's actually pretty. Welcome back. In this video, we will be comparing o3-mini with other reasoning large language models and try to see how does o3-mini fare against the other models on the same problem. So I call this the battle of the reasoning LLMs, and the models we'll be trying out are obviously o3-mini, and we will compare it against OpenAI's o1, GPT-4o, which is not really a reasoning model per se, but we want to see, okay, how does a non-reasoning model also work, which is powerful. And of course, the DeepSeek R1 reasoning model, which is one of the recent models, which is doing pretty well. So let's check out the first problem. Now, this is a twist on a classic problem which involves a man, a goat, and a wolf or a lion maybe, and they are all waiting to cross from one side of the river to the other side, and they have a one boat where 2 people can travel, and they have to do it in such a way that the lion or the wolf is not left alone with the goat, because then the wolf or lion could kill the goat, and so on. Now, these problems are all out there on the internet, and a lot of these have been ingested by these models also. So my idea was, can I present something out of the box, which is actually very simple to a human, but I want to see how do these models really think about it? Because are these really reasoning LLMs, or are they actually just extrapolating from things they have potentially memorized? So my problem is pretty straightforward. A man and a goat are waiting on the riverbank, cross to the other side, and there is a boat. How do they do it? Now, this is a pretty straightforward problem. If you think about it, even if I ask a child, they will obviously say that the man and the goat will get into the boat, and then they will cross from one side to the other side. That's it. It's a very straightforward problem. So now let's see how ChatGPT-4o or GPT-4o in the ChatGPT web interface has fared. So now you can see it tells us that it depends on the constraints of the boat, but if we assume the boat can carry only one at a time, the man first takes the goat, then he returns alone. Now he crosses again by himself. If there are more elements involved, like a wolf or a cabbage in the classic riddle, then there would be additional steps to ensure nothing gets eaten. But actually, I mean, this is just GPT-4o overcomplicating it. If he's taking the goat across the river, that's it. They don't need to do all these steps again. It's just redundant, and this is totally not relevant. So this is where this model doesn't really fare that well. It overcomplicates things way too much. Let's look at how OpenAI o1 fared on this problem. So again, same prompt. And you can see it has reasoned for 31 seconds, that is half a minute. And again, you can see it's kind of extrapolating from things it has already been fed with, right? Data and problems it has already been fed with. Like I'm reflecting on the classic wolf, goat, cabbage puzzle setup, even though there is no wolf, cabbage involved, but it does identify, okay, there's a similar problem to this, but it doesn't really need to think about all of these other constraints. And then it starts thinking about what are the constraints, are there some hidden rules or a trick? And then it starts thinking about a bunch of steps, and it thinks the puzzle might need more detail, like a wolf, a goat, and a cabbage, but it doesn't really need, right? So it's just overthinking stuff here. And then after reasoning for half a minute, it tells us there is a piece missing from the riddle. I mean, I didn't really say it's a riddle, right? I just asked a very straightforward question. And then it says, if your riddle is actually the classic wolf, goat, cabbage puzzle, then it brings into the problem things which I never asked it to do, right? And then it says, instead, if it's a puzzle you literally wrote, then solution is simply the man rows the goat across the boat, which is true. So it does get the right answer, but it starts thinking about things which it doesn't really need to, because I was pretty clear in the question. I did not tell it to think about it as a riddle or think about additional stuff. Now let's see how DeepSeek R1 fared against this problem. So here I am in chatdeepseek.com, and this is the question, same prompt, man and a goat are waiting to cross, and there is a boat, how do they do it? And you can see DeepSeek R1 thought for 48 seconds. So that's close to a minute. That's a really long time. And again, this model also starts thinking about wolf, cabbage, and so on. But it just says that, okay, only man and a goat, then the answer is straightforward. Man can just take the goat across the boat. That's it. It could have probably ended the reasoning here, but then it starts thinking about a puzzle. Maybe it's missing something. So again, it starts over-reasoning or overthinking here. And then after 48 seconds, it tells us solution is straightforward as there are no additional constraints or characters mentioned. Both board the boat, row to the other side, exit the boat, which is good. I mean, it does mention about the wolf and the cabbage and so on, which I never really talked about, but still it did get to the right answer. So DeepSeek R1 probably did the best so far. Now let's see how did the o3-mini model fare against this problem. So I'm in ChatGPT with the o3-mini. Same prompt, man and a goat are waiting to cross with a boat. And you can see it just reasoned for only 5 seconds. It is a straightforward option. Man and a goat use the boat together and cross it. And that's it. That's the answer it also gives us. It doesn't think about the wolf, the cabbage, things which are not even involved, and it gives the straightforward answer. So o3-mini probably did the best, giving us the answer in almost like real time, almost real time, near real time in 5 seconds. And let's look at how did o3-mini with the high reasoning level where it tends to think more, how did that model do? So now I'm with the o3-mini high model and I've typed in the same prompt. It reasoned for 21 seconds. So this is where it starts overthinking really with the wolf, cabbage, and so on. Again, just like the other models, but still it thinks less than 30 seconds, definitely. And it does get to the right answer. Solution is very simple. No trick here. 2 passengers just cross the river in the boat. So overall, o3-mini did pretty well in this seemingly straightforward yet deceptive problem, because it starts making the models think based on other things they have been trained on. So interesting, definitely, that o3-mini, including both the variants available in ChatGPT, did way better than the other models. Let's now look at the second problem, which is a slightly more complex reasoning problem we have also checked out in the previous videos. So let's get comparing. So now this is that classic problem of 8 people who are employees of an organization. They work in 3 departments, personnel, administration, and marketing, with not more than 3 of them in any department. Each of them has a different choice of sport in terms of what they like. And then we have some clues like, okay, Dan works in administration, does not like certain sports. Faye works in personnel with only Alex. Earl and Harry do not work in the same department as Dan, which means these 2 definitely are not in administration. So that would help the large language model to look at these clues and then finally answer the question for us that who are the employees who actually work in the administration department, including Dan, obviously, which is pretty straightforward by using all of this. So GPT-4o starts looking at the clues which have been given, and then it starts breaking things down by assigning personnel employees, administration employees, and it then verifies the employee distribution in terms of the department and the sport based on the clues given and tells us that the administration folks are Dan, Carol, and Betty. And it is actually correct. It does a pretty good job. It does take a few seconds, but it does a pretty good job here. Let's look at how did OpenAI o1 fare on this. So again, the exact same prompt as before in terms of the 8 people, the departments and the constraints and the clues, and who are the employees who work in the administration department. And it reasoned for around 18 seconds, leveraging the constraints and clues we have given. And then it started generating the answer by looking at every person, where do they work, or rather which department and what sport they like. And then in the end, Betty, Carol, and Dan. So again, it gets to the right answer. Let's check out DeepSeek R1 and see how DeepSeek R1 did. So again, exact same prompt. And actually, DeepSeek R1 thought for close to 2 minutes. So interestingly, O1 gave us the answer in 18 seconds. After reasoning for 18 seconds, DeepSeek R1 took roughly close to 2 minutes. And as you can see, it's thinking quite a bit in terms of all of the steps. And then it does a bunch of checks also after breaking it down. And finally, we start getting the answer after it has done all the reasoning. So after 2 minutes, this is the answer where it has started mapping every person to what they like and the department they work in. And overall, it actually assigns the department for every person and tells us also that administration are Dan, Carol, and Betty, and even their sport choice. So pretty comprehensive answer, and also maps the sport names to the people, but does take 2 minutes to get to the answer. Looking at o3-mini, low reasoning effort with the exact same prompt, it thought for around 24 seconds and leveraged our clues and constraints and did all the mapping, including the sport and the department they belong to. So after 24 seconds, it gives us the response in terms of starting with the problem data, the departments, the sports, the clues, and then does a step-by-step reasoning. And it's nice to see that step-by-step it breaks down different people and keep assigning the department and the sport they like based on the clues which it goes through one by one till it gets to the final assignment. And looking at the exact same problem with the o3-mini model with the high reasoning effort, in this case, it actually reasoned for around 8 seconds itself, sets up all the departments, and then gets into it step by step in terms of the clues and does a final verification also till it gets to the results. So overall, it totally depends on the way the model is thinking about the problem. If it starts from a certain point, it may end up taking more time to think about it and get to the answer. But if it starts from a different angle, it may get to the answer quicker. Just like humans think about a problem, and if they think from a certain perspective, they get to a solution faster versus maybe taking the longer way around. So it's interesting to see that these reasoning LLMs are kind of emulating what humans do. Well, not exactly, because so far we don't know exactly how our brain works step by step, but it's interesting to see that it takes that step-by-step route and sometimes considers different angles and different approaches. And overall, o3-mini is doing pretty well against all the other top models we have seen so far, including reasoning and regular LLMs. That's it for this video. I'll catch up with you in the next one. Welcome back. In this video, we will understand and look at how we can access the OpenAI o3-mini model via the API in Python so that we can send out prompts and do everything programmatically. So let's get into the hands-on. Now, the first step is for you to go to platform.openai.com. And once you're in platform.openai.com, you will need to sign up for an account. It's free, but you will need to set up your billing and all of that. So I'm logging in with the account I already have. And once you are inside platform.openai.com, you can see a wide variety of aspects here. So what you need to do is go into settings. You see there is a settings bar right on the top right, which is here. So you click on it, and then you will see API keys. You will need to create an API key here, and then you can leverage that. Once you create it, you'll need to save it in a safe location so that then you can use it in the notebook we will show you shortly, and then you can access the OpenAI model. But remember, you will need to set up your billing here by making sure that you add in your card so that if you have any typical usage, then OpenAI will bill you for it. And we've already talked about the pricing in a previous video. So overall, it is pretty cheap. You can run thousands and thousands of prompts, and the cost will still be less than $1. So now we'll get into our notebook, a hands-on notebook, where the main objective is accessing OpenAI o3-mini via the API in Python. The first step is to install the relevant dependencies. So we will mostly be using LangChain OpenAI to install the OpenAI wrapper for LangChain, which is a very popular framework to connect with LLMs and build generative AI applications. And we will use Rich more for displaying markdown results. So I've already installed the libraries. The next step is to enter your OpenAI API key. This is the key which you would get by setting it up here and making sure that your billing is enabled. So I already have my key, which I will enter here. And after this, we need to set up some environment variables so that the key can be accessed from the operating system environment variables directly through the libraries we'll be using to connect with the OpenAI model. So now I'll show you two things. One is how you can access the API natively through the OpenAI library itself provided by the OpenAI organization. And two is how you can use the LangChain wrapper, which makes a lot of things much simpler. So to connect with the model, first you need to initialize the OpenAI client. Now our key is already put in the system environment. So all we need to do is say from OpenAI, import OpenAI and create an OpenAI client. Now we will use this to connect with models. Now we have a prompt just like we typed in ChatGPT earlier. We have now put it in some text here, which is in the World Government Summit, leaders shake hands with each other once. How many handshakes will be there together if there are 15 leaders, and 4 options. So this is put as a string prompt. Next step, I will call the o3-mini model saying OpenAI client.chat.completions.create. That is the function. Pass in the model name I want to use, which is o3-mini. If you wanted to use GPT-4o, you would change the model here. It is that simple. And I will go with the default o3-mini model where the reasoning effort is. And then I pass in my prompt as a user message so that it understands this is a prompt coming in from the user by saying messages equals. I have just one message here. Role is user, which means user is sending the prompt, and content is prompt. And we run this. We will need to wait for the LLM to process our prompt and then return back the response. So it takes a few seconds. And then we can display the response by looking at the completion.choices0.message.content, which returns the first response back to us, and we display it as a markdown. And we can see it tells us to solve the problem. We can use the handshake formula, which is basically NC2, and it gets the right answer. So that is how you access the o3-mini large language model through the OpenAI's API, which is pretty straightforward. So now let's see how we can do the same thing in terms of accessing the OpenAI o3-mini LLM through the API using LangChain. So LangChain is a nice library which can help in building generative AI applications, agentic systems. The first step is to import Chat OpenAI. That is the wrapper which internally accesses this API for us and gets the response from the relevant model we will pass in. So here we import Chat OpenAI and then initialize a connection to the model saying, I want to use o3-mini model and reasoning effort is low. So this creates a connection to the o3-mini model using our API key whenever we will call it. And now we already have the prompt from before. So all we do is we say llm.invoke prompt, and it sends it to the o3-mini model in OpenAI servers, and we get back the response in a few seconds, and we can then look at the response, which is the exact same response. So overall, this is how you access it through LangChain, which is just a one-liner where you mention the model name, and then you just do .invoke prompt. Now, the challenge with this is if the model is returning a really large response, it will wait till it gets back all the tokens and then only it will show it. So the advantage in LangChain is it provides you functions to start streaming the results live. Remember, when you type in ChatGPT, you can start seeing the results live. It does not wait to get back the full response from the model before showing to you. So the way to do that is pretty straightforward. We just say for token in llm.stream prompt, print token.content end. And you can see whenever you run this, it will start returning the result live. So that's a really nice way in which you can start getting the response tokens back from the model using llm.stream your prompt and start printing out those tokens. Now let's check out a different problem now with the LangChain wrapper. So now let's say we have a prompt how to get a number 100 by using 4 sevens and 1 1 and list all the possibilities. So using 4 sevens and 1 digit number 1, how do you get number 100? And then we stream the results by doing llm.stream. So let's check it out. Let's run this. And you can see that it is probably taking some time to think, and now it is streaming the results live, as you can see. And it tells us that unless additional operations are allowed, 177 minus 77 equals 100, and it has used 1 digit 1 and 4 sevens. So now let's look at with the reasoning effort set to high. So here, all I do is I make the LLM chat OpenAI o3-mini reasoning effort equals high, and then I start streaming the results. Remember, it will first reason internally and then it will return the response. So it will take some time because it does not show the reasoning responses in the LLM directly when we call it through the API. And you can see it actually took over 2 minutes in this case to generate the response, and it's streaming the results live. And it gives us 2 possibilities in this case. One is 177 minus 7. The other one is 7 plus 7 times 7 plus 1 by 7, which also gives us 100. So with the reasoning effort set to high, we actually got a better solution for this problem. Hopefully you got a good idea in terms of how to use the o3-mini model through the API. One is natively through the OpenAI API itself, where you initialize the client, call client chat completions create with o3-mini, set your reasoning effort, pass in your prompt, get the response, and then just view it. The other one is through LangChain, where you just use chat OpenAI, pass in the model name, the reasoning effort, and if you want to get the response directly after it has been generated completely, use llm.invoke prompt, response.content gives you the response, else you can do llm.stream and stream the results live as you keep getting tokens from the API. That's it for this video. I'll catch up with you in the next one. Welcome back. In this video, we will be comparing OpenAI's o3-mini model versus other reasoning LLM APIs in Python. So let's get started with the hands-on. So here we are in a Jupyter notebook now, and the focus is to compare different reasoning LLM APIs with o3-mini on the same problem. Now we will install the LangChain OpenAI dependency and LangChain, obviously, because we'll be accessing the models through LangChain. And we also install the LangChain DeepSeek library that will help us to access the DeepSeek R1 model, because we'll also send the prompts to DeepSeek R1 and see how it is doing versus o3-mini, o1, GPT-4o, the models which we looked at in the previous module also inside ChatGPT and ChatDeepSeek. So I've already installed these libraries. The next step is to enter your keys. So we already discussed you can go to the OpenAI platform and get your OpenAI API key. Similarly, you can just go to the DeepSeek API platform and get a DeepSeek API key and enter them here and set up the environment variables so that when we call the libraries in LangChain, it will access these keys and access the models directly without us needing to enter the key again and again in the code itself. Next step, we create a connection to the different LLMs. We will be using a total of 4 LLMs here. One is o1 preview. So we do chat OpenAI, model is o1 preview. Then we do chat OpenAI, model is GPT-4o for the GPT-4o model. This is, by the way, for the o1 model. and then Chat OpenAI o3-mini for the o3-mini model, and similarly Chat DeepSeek for DeepSeek Reasoner, which is the DeepSeek R1 model. If you want to access the older DeepSeek V3 model, you would have to type in DeepSeek-chat. Here we are going with the Reasoning LLM, the more powerful one. So the idea is we will go through a couple of problems, and the exact same problem, we will run through all the models, look at how much time did it take to get to the answer and whether the answer is making sense or not. And in that way, we will compare the different reasoning and regular LLMs together. So now that we have the connection to the 4 LLMs, let's start off with the first problem. The first problem is how to get a number 100 by using 4 sevens and 1 1, list all the possibilities. That is my prompt. I start off with OpenAI o1, so I will also time how long does it take to get the response. So I use the time library in Python, start off the time here, and then I do for every token in the o1 LLM.stream, pass in the prompt, print the response. So stream the results live, and then after I get back the full response for this prompt from o1, finish the time computation and show me the total time taken. So as you can see, it gives us the response here that 177 minus 77 equals 100. So that is the solution it tells us, and it took it roughly close to 1 minute. And then with GPT-4o, exact same code. The only difference is we are sending the prompt to the GPT-4o model, which we initialized earlier. That's the only difference. Everything else in the code remains the same. And this is the response from GPT-4o, 177 minus 77 equals 100. And it took only 5 seconds, which is pretty nice. Then we stream the results live from o3-mini. And you can set the reasoning effort directly here when you're passing in the prompt. So here it is regular o3-mini with the reasoning effort set to low reasoning level, and it gives us the solution right away, which is 177 minus 77, and it tells us there are other possibilities also could be possible, but this is the main one, and it takes around 9 seconds, which is not bad for a reasoning LLM. And then exact same problem, except we are using the reasoning level set to high for o3-mini, and you can see that it gives us one acceptable answer, and then it also gives us some other possible answers which are actually on the right track. Of course, some of them it is dividing 7 by 10, which may or may not be acceptable, 1 by 10 into 7, but overall, in all the cases, it has used 7 4 times and 1 once. And it took around over 2 minutes, close to 2.5 minutes to give the answer. So reasoning effort high gives us more options towards the answer, but it takes longer. Let's check out the response from DeepSeek R1. So here we send the prompt to DeepSeek R1, which we connected earlier, and it gives us just one answer, but it took around 445 seconds. That is a really long time, but the answer is not as good as o3-mini in this case. So pretty good job by all the LLMs all around, but o3-mini probably the best one, with o3-mini reasoning effort low giving us a really fast response and high giving us more options. Let's now look at the second problem. So in problem 2, we give it that classic problem which we saw in the earlier module, where a man and a goat are waiting on a riverbank to cross to the other side, and there is a boat. How do they do it? And then from OpenAI o1, we get the results, where it starts thinking about a bunch of stuff that, yes, goat can take both the man and the goat to the other side, but again, man takes the goat, leaves it on the other side, returns alone, process again, which again doesn't make sense here. So it does give us the right solution, but it starts overthinking also, and it took around 15 seconds, which is not bad for a complex reasoning model. For GPT-4o, it gives us the wrong answer, which is man rows across with the goat, again comes back and again takes himself, which doesn't make any sense. Result comes out faster, obviously, because it's not a reasoning LLM, but it doesn't do that well. With o3-mini, setting the reasoning level to low and getting the answer. The trick is that the boat can accommodate both the man and the goat at the same time. Man gets into the boat, brings the goat along, rows to the other side. That's it. Classic. Simple, straightforward answer in only 5 seconds. Pretty much the best answer. Setting the reasoning level to high, it takes around 35 seconds. It does think about the other aspects which are typically in this problem, but it does get to the answer that they simply both cross together in the boat. And for DeepSeek R1, we send it to DeepSeek R1. Solution is straightforward since two characters involved, man and the goat. They both go to the other side. It does think about the other aspects typically associated with this problem, but it does not let that sway its reasoning. It does take a bit longer, 40 seconds, but does a pretty good job. So overall, DeepSeek R1 does pretty well, but in many cases takes more time. But o3-mini reasoning level low does pretty good on most occasions. And you could go with reasoning level high in case you want to dive deeper, look at a variety of approaches, potentially possible approaches to the same problem. That's it for this video. I'll catch up with you in the next one. Welcome back. In this video, we will go through a hands-on demo of using o3-mini in the API. And we will look at the different reasoning levels offered by OpenAI in terms of low, medium, and high. And we'll do an analysis on certain problems and look at the outputs, the computation time. So let's get into the hands-on. So in this hands-on, the main objective is to compare the three reasoning levels of OpenAI's o3-mini model available in the API, which include the high, medium, and low reasoning levels. For this, we install two dependencies, just like our previous hands-on demos. We will install LangChain OpenAI and LangChain to access the OpenAI models through LangChain. And then we enter the OpenAI API key, which we discussed earlier, how you can go and get it, and then set up the environment variable so that LangChain can use this key internally to access o3-mini. Next step, let's start accessing the API and look at a couple of reasoning problems. So for the first reasoning problem, it is a very simple math-based reasoning problem that if the cost of a bat, a baseball bat, and a baseball combined is $1.10, and the bat costs $1 more than the ball, how much is the ball? So that is the overall problem, that both combined cost 1.10 and the bat by itself costs $1 more than the ball. How much is the cost of the ball? So now let's look at o3-mini and see how we can use the different reasoning levels available in the API and what is the impact on the output in terms of computation time and the results. So the first step, you initialize the model. Chat OpenAI model equals o3-mini, start the time computation calculation, and then for token in LLM.stream, pass in the prompt and set the reasoning effort to low, which means use the low effort setting in the reasoning model for o3-mini and give me back the response live. And then end the time computation after the response has been obtained. So overall, it tells us let the cost of the ball be X dollars, bat costs $1 more than the ball, so the bat costs X plus $1, and then it just puts it into a simple linear equation here, simplifies it, gets to the answer saying that the ball costs $0.05, which is 5 cents, which is correct, and it took around 2 seconds to get to the answer. Pretty nice. Now we run the exact same prompt. The only difference is we are getting the response from the LLM using reasoning effort set to medium. That's the only change you need to make to use the medium reasoning level in the o3-mini API. And then again, you can see it is pretty much very similar, just that it is slightly different in terms of the overall language it is using really, but overall, pretty much the working, the computation, the step-by-step computation for this is very much similar. And it tells us the ball costs $0.05. Time taken is 3.57 seconds. Earlier, it was around 2 seconds, so slightly longer time. And now let's look at with the reasoning effort set to high. For that, all we do is exact same code, exact same model, just that LLM stream, the reasoning effort is set to high. And we can see here that, again, the computation is pretty much similar, just that probably it will think a bit more when it is breaking it down into steps for each step and then gives us the response. And it tells us that the cost is $0.05, which is also 5 cents. Earlier, it was just telling $0.05, or in this case, 5 cents. But here it tells us both the values, which are both correct. And here the time taken is 7 seconds, which is roughly double the time taken for the medium reasoning level model. So overall, it gets to the correct answer in all three cases. In fact, what you will see is usually the low reasoning effort level in the o3-mini model is pretty good for most cases, but in case some problem doesn't get to the right answer for you or certain problems you're tackling, then you can increase the reasoning level effort. Just remember the time taken for reasoning and getting to the answer might be longer. Let's look at a second problem now, which we have also seen earlier, which is that same reasoning problem that there are certain people who work either in personnel, administration, or marketing. They have certain preferences in terms of sports based on the given constraints and clues. Can we say who are the people who work in the administration department? So it's the exact same prompt we have used earlier, where we have 8 people, employees of an organization. They work in 3 departments: personnel, administration, and marketing, with not more than 3 in any department. They have some preferences for sports, and these are all the clues. The idea is for the LLM to go through this and then tell us who are the employees who work in the administration department. And now we use the same model, new prompt, which we just initialized, and reasoning effort set to low. And you can see that the model lists out employees, departments, sports, clues. Start using the clues step by step for each person, and finally get to the answer in 12.86 seconds. Next one, same prompt, only thing is o3-mini reasoning effort set to medium. And here it starts listing out, it takes a slightly different way of going about it. It starts listing out what is available, and then it starts looking at entire departments instead of looking at every person individually. So it takes a slightly different approach, and then it verifies all the clues, which is interesting. It's doing some fact checking based on what it has done for every department. And then it finally gets to the answer, which is correct in terms of both the sport assignment for the people and the people, obviously, who work in administration. Time taken was roughly 28 seconds, which was almost like more than double of what it took for the low reasoning effort level in o3-mini. And finally, let's check out how is the response for the reasoning effort level set to high in o3-mini for the exact same prompt. So in this case, it again starts with the employees, the departments, the clues, and then it starts looking at every person step by step, looking at the departments, also in this case, looking at the sport assignments. And as it is looking at every clue, it starts looking at all the 3 things: people, departments, sport interest, does some fact checking, and then the final assignment. And it does a pretty good job in terms of the 3 people who are in administration. And it takes 33 seconds roughly for this, which is slightly longer than the medium reasoning effort level. So overall, again, depending on your problems, you can start off with the default low reasoning effort. And if you feel like you're not getting to the results you really need, or you're tackling more complex problems, don't hesitate to go with medium or high reasoning levels in o3-mini. Just remember, it will take longer to get to the result. And with this, we come to the end of the course. So hopefully you got a good idea about OpenAI's o3-mini model, the different reasoning levels, benchmark results, performance, pricing, and how does it fare with other reasoning and regular large language models, both using ChatGPT and a hands-on demo in Python. Thank you.